Well, hello and welcome YouTube. Mr. Robinson back here with yet another brand new exciting video, all math-based of course, and as always, it is an honor and a privilege to be serving you here today, as it is every day here in my virtual classroom. Alright, step on inside here, and we are going to go pretty rapid fast. A little day 1 review from our polynomial factoring and solving unit, and then I'll give you a day 2 one on top of it. And like I said, this is going to be fast. I got 22 questions, but I won't be surprised if I do them in about 10 minutes or so. Mostly doing, a lot less teaching. I'll talk over some of the work, but I'm jumping straight into it. We got in this set, just so you're aware, we got simplifying expressions through subtraction and addition, multiplying expressions, binomial 2 by 3, 3 by 3, some special cases right here, expanding binomials of larger degrees right here, and on the back side, a bunch of factoring of different things. They don't really get into, this is a cubic, but you can probably see a GCF right there, so quadratics, factoring, and then solve quadratics by factoring. And that's it. So let's dive into it right now. Simplify each expression. Number 1, we are going to rewrite these guys right here. I could probably do standard form right there if I wanted to. Oh no. And then subtract right here by distributing the negative into these terms. I'm going to find my highest degree polynomials, x to the fourth, 3x to the fourth plus 3x to the fourth right there. I got a 3x cubed right there. I have no x squared, 2x plus 5x, and then 5 minus 3. And then that is my result of that. Number 2, we have multiple things there. I'm going to try and do some standard form-esque things. I got an x to the fourth there, a 2x and a 3, and then minus the negative, or minus the positive and then minus the negative here. And then plus, keep the signs the same here. I'm going to write the negative 3x first there. That doesn't really help too much, I guess, because still got to find standard form-esque stuff. 3x to the fourth is first. No x cubes, I got a negative 7x squared and a 5x squared. 2x, 5x, negative 3x, 2 plus 5 minus 3 is 4. And then constants 3 plus 5 is 8. Alright, number 3 here, we're going to multiply these guys out. 4x is going to multiply with 8x squared, 5x, and 1. 3 is going to multiply with 8x squared, 5x, and 1. It's kind of hard to write something different from what I'm saying out loud. And when I add those, like I said, I'm going to try and do this a couple of times here. 32x cubed plus 44x squared plus 19x plus 3. When you combine like terms there. Then a 3 by 3. We got a few more ones to take care of this time. So 6x squared with 3x squared, we get 18x to the fourth there, so plus 7x minus 1, 6x squared. Then 5x, that'll line up with the x cubed and x squared in an x term, so we'll get 15x cubed, and then 35x squared, and then negative 5x. And then negative 7 goes with this one's negative 21x squared, and then negative 49x, and then positive 7. Add those up there, we get 18x to the fourth. And by the way, these are standard form, everything in standard form here. 18x to the fourth, looks like 57x cubed. And I hope I'm doing this right, going this fast. Negative 27 plus 35 is 8. And then negative 54x and 7. But yeah, I hope I'm getting those things right. At least the idea is correct, right? Whether or not these are correct answers, I sure hope they are. 3x plus 2 quantity squared. We square the first term. We double the product of 3x and 2, so double 6x is 12x, and then we square the 2 to get 4. Like I said, I'm going to go straight into it. This is kind of what I'm expecting my kiddos to do in these situations. Same thing here. You square the first term, double the product of these two. That's negative 24x, doubling negative 12. And then squaring that last term there. And it is a positive. We get a plus 9 right there. Perfect square trinomials. That's how they show up. You don't just square those two guys. These are differences of two squares right here. 7x plus 5, 7x minus 5. Square the first term, square the last term, subtract the result. Boom. And then right here, same-ish, 5 plus m, 5 minus m. Square the first term, square the last term, subtract the result. This is not standard form, though. In standard form, we'd have to have this term first and then that term right there. So that's good for me. Even though it's a leading negative, that's fine. That's how we're going to work things. And we're going to graphing polynomials kind of after this stuff. You're going to start seeing some videos on those ones. Okay, expand completely. I have some old videos on them. Expand completely. We have a 4th degree and 8th degree polynomial. I'm going to build Pascal's triangle up to 8 degrees here. 9 rows up to row 8. So here's row 0, row 1, 2, 3, And technically, I know them up to 4. I probably should have just started there. But 4, 5, I guess I know that one too. 6. I've seen these up. I don't see them past 6 very much. So it wouldn't surprise me if I didn't like know for sure what some of these numbers were. 7. And then 8. And I'm going to have to move this a little bit now after. But I need these numbers here for this guy. 56, 70, 56, 28, 8, and 1. Okay, Pascal's triangle up to that. So I'm going to use those coefficients depending on the problem that we're kind of taking care of there. So I guess I can slide this up because reasons. Okay, there we go. All right, 2m plus 1 to the 4th power. So row 4 is the 1, 4, 6, 4, 1. So I'm going to go ahead and multiply by 1, and 2m's to the 4th power, 1's to the 1st power. And then 4, 2m is cubed, and 1 is, you know what? These are 1s, right? But here, I'll write this. It's to the 1st power. 1st power, and then 1 will be squared and cubed. We're not changing anything there. It's just plus 1. So I'm really not going to write those. 6 times 2m squared, and then 4 times 2m to the 1st, because again, 1 is to whatever power. And then here I do need that. 1 times 1 to the whatever power. That's fine. 2 to the 4th is 16, so 16m to the 4th plus 2 cubed is 8, times 4 is 32. 32m cubed. 2 squared is 4, times 6 is 24. And 4 times 2 is 8, 8m plus 1. I don't need all this room. I don't even know if I need all this room for this problem either. It's just Pascal's triangle has had to be built. Let me move myself, though, in case I need to front and center. All right, over here. Now, this one actually is as straight up as you can get. In fact, I'm not going to add more work to this thing. As straight up as you can get, x gets the 8th, y to the 0. So that's 1, x to the 8th. And then 8, x to the 7th, y to the 1st. And then 28, x to the 6th, y squared. It's literally this. There's no other coefficient thing to take care of. This is actually a pretty clean problem once you have Pascal's triangle taken care of. 70, I have to go down the next line, though, after this, though. X, oh my gosh, x to the 4th, y to the 4th. 56, x cubed, y to the 5th. 28x squared, y to the 6th. 8x, y to the 7th, and then 1, y to the 8th. 9 terms. 1, 2, 3, 4, 5, 6, 7, 8, 9. All taken care of there. Okay, awesome. Okay, it won't be 10 minutes long, but you know what I meant. Okay, let's keep moving forward. Factor each completely. I got a greatest common factor of x here, and I'm left with x plus 10, and that's it. We're not solving that, just factoring there. I'm going to leave the same color for all these. Try to find out what two numbers multiply to negative 54 and add to 3. That's 9 and negative 6. You know what? Maybe I do get it in that time. GCF of 3 exists in number 13 there. You get x squared plus x minus 30. Now we find two numbers that multiply to negative 30 and add to positive 1. That's 6 and negative 5. Remember that 3 stays on the outside. GCF of 2 right here. Find two numbers that multiply to 18 and add to 9. That's 6 and 3. No GCF this time, so that 5x is a part of our factorization, assuming it can factor, and there's good reason to assume it can. I'm going to choose even factors of 64, either 8, 8, 16, and 4, 32, and 2. I'm going to start with 8 and 8. That's probably a good guess here. That'll be 40 plus 8 is 48, so that one works out. It's good to start in the middle ones there. It's not often that we're actually getting ones that have multiples beyond 12. In fact, I don't know if they even set them up that way. Common factor here, 2, maybe 3. 1 plus 3, 8, yeah, 3. If 2 and 3 both work, then so does 6. So I'm going to factor a 6 out of there. That should be able to work. We get 5x squared plus 120 is 20, so 23. 23x minus 240 is 40, and 42 minus 42. So that looks good and all broken down there. Another 5x going on here. I'm going to try 7 and 6 first with this. Let's try 6 here. That'd be 30. 30, whoops, plus 6, so 30, and then minus 7. I think that should work. So again, this is just me. I don't know this, but this is kind of how I work this stuff out there. But 30 minus 7 is 23 there, and that's factorization. Right here, it's either 9 and 1 or 3 and 3, because this number's a little bit smaller with that. I'm going to try 3 and 3. No common factor, by the way. And not a perfect square trinomial either. Just because this is squared and this is squared, this isn't double 3 times 2. If this was a 12, yeah, and if this was a plus, okay. 4. Let's try 4 and 1 or 2. It can't be 2 and 2. It's not a perfect square trinomial. Oh, but that'd be 6. Let's do 4 and 1. Yeah, plus 4 minus 1, I think, works. 12 minus 3. Okay. Got a GCF of 2. I think 6 works again here. 6. It might be something bigger. 9x squared plus 24. X plus, I think, 16. I think that's as big as it gets. And that looks like a perfect square trinomial. We square 3. We square 4. And then we double 3 times 4, which is 12. So that's that. No GCF. We'll try 7x and x. I'm going for 5 and 5 business here to get 30. It's plus 5, 35. Minus 5 is 30. And last one, GCF of 5. X, it looks like. I didn't even note the 5 last time. You get 2x squared plus 3x plus 1. And that can only come out to, if possible, 2x plus 1 times x plus 1. Because factors of 1 are just 1 and 1. So let's see that. 2 plus 1 is 3. And that works out there. Okay, right here, solve by factoring. We had something like this before, right? Oh, plus x minus 30. So that's plus 6 minus 5. So this is x minus 6 times x. I didn't need to know that. I was just seeing if it's the same. Factor set equal to 0. And we get x equals 6 or x equals negative 5. And lastly, right here, there's a GCF. You could factor it out. We could also divide it out now that it's set equal to 0. Divide both sides by 2. You get 5m squared minus 34m minus 7 equals 0. Factor that. 5m and m looks like negative 7 and positive 1 this time. Negative 35 plus 1. So this is negative 1/5. Subtract 1 divided by 5. And then add 7 right there. And that's it. All right, so that'll do it for this one, guys. There's going to be a day 2 one here as well. It's going to be probably a little bit longer than this one. Even though there are less questions, there's more work to be done. Thank you for watching. Take care, and I'll see you in the next one.